Welcome back to EtherLink AI Insights. I'm Alex, and today we're diving into a topic that's reshaping how enterprises build AI systems: Agentic AI development and multi-agent orchestration heading into 2026. If you've been following enterprise AI, you know we've moved way beyond simple chatbots. We're now talking about coordinated networks of AI agents working together on complex business processes. Sam, what's drawing so much attention to this shift right now?
Great question, Alex. The numbers tell the story. We're seeing 73% of enterprise leaders actively deploying AI agents in mission-critical workflows. That's huge adoption. But here's the tension. 62% of those same leaders admit they have governance gaps and aren't truly production-ready yet. So companies are moving fast, but they're also exposed. That's the inflection point we're at.
So they're deploying without fully understanding the risks. That sounds like a recipe for some expensive mistakes. What specifically breaks when companies try to scale from a single AI agent to a more complex multi-agent system?
The failure modes are pretty clear when you look at the data. A standalone LLM chatbot hits a capability ceiling fast. It can't maintain state across your fragmented business systems, it can't reason deeply about domain-specific problems, and, critically for regulated industries, it can't maintain the audit trails you need. Gartner found that 58% of enterprise AI pilots fail to scale beyond proof of concept, and a lot of that is architectural brittleness.
58% is a staggering failure rate. So let's talk about the solution. How do multi-agent systems actually solve this problem? Can you walk through a concrete example?
Absolutely. Imagine a travel booking platform. With a single agent, you're asking one model to check flight availability, compare prices, execute the booking, and ensure regulatory compliance across different jurisdictions. That's too much. With multi-agent architecture, you deploy a retrieval agent that indexes flight data, a pricing agent that runs comparisons, a booking agent that handles transactions, and a compliance agent that validates regulations by region. Each agent is specialized, focused, and accountable.
That makes intuitive sense. Divide and conquer. But now you've introduced a new complexity. How do you coordinate all those agents? They need to talk to each other, right? What are the main orchestration patterns enterprises are using?
There are three dominant patterns. First is hierarchical orchestration, where a supervisor agent breaks down requests and delegates to specialists. It's clean for well-defined workflows, but the supervisor can become a bottleneck if it gets too complex. Second is workflow-based orchestration using DAGs, directed acyclic graphs, which define agent sequences up front. This dominates regulated industries because it's auditable and deterministic, which is non-negotiable when you're under something like the EU AI Act.
So the workflow approach is deterministic. You can trace every decision and step. That's huge for compliance. What's the third pattern?
Market-based orchestration, where agents bid for tasks and negotiate resource allocation dynamically. It's elegant in theory, agents self-organize based on capability and load, but it's emerging and still risky in production because you need really mature governance to prevent agents from becoming misaligned with your business objectives.
So market-based is the frontier stuff, still experimental in most enterprises. That brings us to governance, which you mentioned is critical. What does production-ready governance actually look like for these systems?
Production-ready multi-agent systems need three pillars. First is orchestration clarity. Every agent knows its role and dependencies. Second is state persistence. The system has to remember context and transaction history across agents, across time. If Agent A talks to Agent B, and then Agent C needs context from that conversation, you need to track it. Third is compliance transparency. Every decision gets logged, attributed, and made auditable.
Those three pillars make sense individually, but they're all interconnected, aren't they? If you're weak in one area, the whole system becomes fragile.
Exactly right. Most enterprise failures we see stem from neglecting one of those three. Some companies nail orchestration but lose track of state. Others implement logging but don't enforce clear role boundaries. Under EU AI Act constraints especially, all three have to work together. You need clear governance documentation, you need to trace decisions, and you need to maintain system integrity across distributed components.
Let's talk about the EU AI Act for a moment, since you mentioned it. How does that regulation specifically impact how you'd architect a multi-agent system?
The EU AI Act raises the bar considerably. It requires transparency about AI system capabilities and limitations, documentation of how AI systems are tested and validated, and crucially, human oversight mechanisms for high-risk applications. For multi-agent systems, that means you can't just let agents operate autonomously without checkpoints. You need designed-in human-in-the-loop controls, you need to classify your agents by risk level, and you need documentation that ties back to training data, testing protocols, and decision logic.
So it's not just technical architecture, it's governance and documentation as code, essentially. If you're implementing this, where do you actually start? What's the roadmap?
Start with a governance maturity assessment. Map your current AI deployments. Identify which are mission-critical, assess your documentation gaps, and classify risk. Then, build your orchestration framework incrementally. Most enterprises start with workflow-based orchestration because it's deterministic and auditable. You define your agent roles, their dependencies, and failure modes up front. Then you implement state persistence, usually a combination of conversation logs, transaction databases, and audit trails. Finally, you instrument monitoring and compliance dashboards so you can report to regulators and internal stakeholders.
That sounds like a phased approach rather than a rip and replace. How long does this typically take for a large enterprise?
It varies, but realistic timeline is 6 to 18 months depending on organizational complexity and existing technical debt. You're not just building software. You're establishing governance processes, training teams on new mental models for how AI systems should behave, and building documentation and monitoring infrastructure. The companies that move fastest are those that treat it as both a technical and organizational transformation.
That's really important context. Before we wrap up, what's the single most important action an enterprise leader should take right now if they're thinking about building multi-agent systems?
Stop treating AI governance as an afterthought. Start with governance requirements, then design your architecture backward from those requirements. Define your risk classification scheme, specify your audit and logging requirements, and only then architect your agents and orchestration. If you reverse that order, build agents first, add governance later, you'll either face expensive re-architecture or operational risk. Governance first is the path to production readiness.
Governance first. That's a crisp takeaway. Sam, thanks for walking through this. For folks listening who want to dive deeper into the specific patterns, implementation strategies, and governance frameworks for EU AI Act compliance, head over to etherlink.ai and find the full article on Agentic AI Development for Enterprises. We've linked it in the show notes as well. Sam, thanks again.
Thanks, Alex. Great conversation.
And thanks to you, listeners. We'll be back next week with another insight on AI transformation. Until then, this is EtherLink AI Insights.